Hi, everyone. Thank you so much for joining us today. My name is Vikas Bhatia, and I am the head of product for Azure Confidential Computing. Today, we will be talking about new developments for protecting your data in use with Azure Confidential Computing. So today, we will be providing you with an overview of confidential computing if you're not already aware. We will show you a couple of patterns for how you can make your app confidential. And then we will talk about how the Azure cloud is moving to be the Azure Confidential Cloud with some of the solutions that we are providing from Azure that can make your workloads confidential when running in the Azure cloud. One other thing I want to point out, right at the bottom of this screen and in a few more other slides, you will see that link at the bottom, which you can use to get in touch with us. It's a simple form where you can come in and tell us what areas you're interested in, and this will allow us and our product teams to come in touch with you if you're interested in joining us on this journey. So let's get right into it. First, we're going to cover what is Azure Confidential Computing. What Azure Confidential Computing lets you do, it lets you move forward on your digital transformation. It helps you migrate with confidence your privacy and security sensitive workloads to the cloud. It also helps you unlock new opportunities by leveraging many of the services that are provided in the Azure cloud, such as Azure Machine Learning or using Azure SQL. And it also helps you innovate with confidence. There are so many times when you want to do so many things with data, but you cannot because of privacy and security limitations that you have in handling with the data. Some of them have to do with just the quality of data that you have. The other have to do with there are regulations that you have to deal with in operating your data. So what Azure Confidential Computing lets you do is helps you protect your data in use for giving you that added security for your privacy and security sensitive workloads and to enable scenarios such as secure multi-party data sharing. So when we talk about three legs of a data protection lifecycle, what we mean is we have existing encryption that we use today for protecting data at rest and protecting data in transit. For example, to protect data at rest, most of the disks that we use have disk encryption already enabled, such as BitLocker. Or for data in transit, today when we send data over the wire, we always use HTTPS or TLS or some sort of encryption that makes sure our data is protected the whole time. But as an industry, when we are actually operating on the data, when the data is actually being used, when it is in memory, that data today is completely in the clear. So what ACC lets you do, it helps you protect that data in use. And what it helps you, it protects against malicious privileged administrators or even your own insiders or hackers who are exploiting bugs, say in the hypervisor or the operating system, whether that's the guest or the host operating system. And it also helps you protect your data against third parties who you want to share the data with to enable a common business desire, but it helps you protect that data so that the data cannot be accessed without customer consent. So why do you need to protect that data in use? Because you as an app developer have done everything you can to protect your application. You've gone through the threat models, you know what your trust boundary is, you know all the applications and libraries that you're including in your application. But when your application is running in a cloud environment, it is running with other apps on the same guest operating system. That guest operating system sits on a hypervisor or a host. And when your application is running in the cloud, it is exposed to these attack vectors, such as vulnerabilities in the guest OS or the host OS kernel or the hypervisor. In addition, there are human elements here, right? Your own trusted VM admin, your own tenant admin, maybe having a bad day or their credentials might be phished. In those scenarios, what happens is somebody might be able to say install a malware or something on a guest operating system, which now has access to your data that you did not really anticipate in your trust model. So as you see now, this is the same picture from the previous slide. And now what we help you is we've been working very closely with Intel as a close partner where your code and data can now run securely inside an enclave or a trusted execution environment. So in this model, your code and data is only ever in the clear when it is inside that protected enclave that is backed by a key that you own. So what this means is data is only ever in the clear within that protected memory. within that protected enclave, and it is encrypted the second it's pushed outside the CPU. So how does this work? We've been working very closely with Intel on their SGX hardware. SGX stands for Software Guard Extensions. This is a new hardware architecture, new instruction sets that lets you set aside these private regions or enclaves of code and data where the data is only ever in the clear when it is inside the enclave. As you can imagine, this is a really powerful concept because now your application, as it was exposed to all of these other vectors before, is now protected from those different vectors, such as bugs in the hypervisor and human element that were mentioned before. And as Azure, we are now generally available in a variety of regions around the world. These are some of the deployments that are available today, and there are a few coming down the line. And we expect to be in 13 regions by the end of 2020. So what you can let us do is let us know which region you're interested in, and we will try to get a cluster very close to where you are. So what use cases is confidential computing useful for? Here is an example use case that we've been working with a few of our customers on. Let's say you're in the banking industry and you want to detect fraud, right? There's some sort of fraud happening in your transactions and you don't quite know what is happening. You only have access to your own data set. So when you have access to only your own data set, the amount of detection rates, the false positives that happen in that case are pretty high. Ideally, what should happen is that these banks can pool their data together and operate on the common data so that you can run machine learning models or plain old analytics for the combined data set running inside the enclave. But the challenge, as you can imagine, is these banks can't just share data with each other because of regulatory and privacy and security concerns. What confidential computing allows you to do, it allows you to run agreed upon analytics on the combined data set where you can still get those insights without giving access to that private and sensitive data, and thus meet the confidentiality requirements that we have on these sort of data. And then as an outcome, you have increased detection rates, you're reducing the false positive. And what this lets you do is help you collaborate and explore new business models that were previously not possible. In addition to this particular use case, I also want to talk about other use cases that we've seen in the wild. So for example, we've seen customers leveraging privacy-preserving analytics, such as for multi-party data sharing and computation. Payment processing and cryptocurrency is another common use case. Blockchain is a common use case. Another use case that we've seen really resonate with customers is machine learning for machine learning inferencing and training. Similarly, for key management or secure databases. The last line is important because the data itself is something that needs to be secure. We secure it when it is stored at rest. But today, by leveraging confidential computing, you can secure that data even when it is in use. The other thing I want to call out is we've seen a bunch of interest from regulated industries for the reasons that you might think are pretty obvious, because these regulated industries have strict guidelines on how they operate on data. So we've seen a ton of interest from financial services, government, and healthcare. So what I want to talk to you next about is a couple of customer successes that we've seen in this space to give you an idea of the kind of use cases and workloads that we are seeing with confidential computing. Another use case I want to highlight is a partnership with MobileCoin. So MobileCoin enables digital currency transfers between users. And if you've used any of them, they are typically not very user-friendly, and these transfers can take a lot of time to accomplish. What MobileCoin does is it leverages the Azure Confidential Computing platform to provide a new digital currency and a platform that provides that fast, secure transactions, which also gives you that great user experience. And the confidentiality that can be accomplished with ACC is something that they really value. As you can see here, even the administrator cannot see the data unencrypted. This is the promise where confidential computing will help us move the industry from computing in the clear to computing confidentially. So we'd love to talk to you about a customer use case that we've been working with Magnet and Region. Magnet is one of the leading grocery retail chains operating more than 22,000 stores in over 5 formats. And they want to enable a loyalty card where they want to actively collaborate with their partners and payment providers so that you can have secure, rich data collaboration such that the privacy is maintained when you're doing these joint analytics when they're working with their partners. This has been enabled through Agregion, who is an ISV partner of ours. So what I want to show you next is how you can use the various components that you have as a customer and the capabilities we provide in Azure to provide that seamless integration. So the business outcome that we're looking for here is leveraging secured analytics. Can we do BI and analytics on joint data, a combined data, so we can get richer insights for these combined loyalty cards while still maintaining that confidentiality? So from an architectural perspective, the data is stored and processed at the partner's cloud data lakes, and the processing nodes themselves are not quite determined beforehand. The partners, they release a joint analytical product and grant access to the specific data areas based on specific terms. So what happens here is they create these dedicated secure enclaves that are used for that sensitive joint calculations, such as ID matching or joint processing. And these enclaves are signed for execution strictly based on scripts so that nobody can get access to the data inside that enclave. All data input and output are encrypted. All operation logs themselves are stored in secure, irreversible distributed registers. And AKS, or Azure Kubernetes Service, is used for executing and orchestrating the containers, scaling up and down based on the needs or the data size. So over here, I brought a few concepts that I haven't introduced here, such as Azure Kubernetes Service. Later on down the slide, I will talk about how you can use AKS for doing your confidential workloads. As a developer might be thinking, how do I make my app confidential? So when we talk about confidential apps, at a very high level, there are two application programming models. The first is you have a new app that you want to bring to the market, right? Or something for your customers. Here's a new app. You are very sensitive to the amount of code that you're running inside your trusted computing base or your TCB. A TCB is generally defined as the amount of code that you trust and you know is running for your application. In this particular scenario, when you're building a new or you're refactoring an existing app, you have the most control where you can leverage one of these SDKs that we have listed, such as the Open Enclave SDK or the Intel SGX SDK, the InRx SDK, the CCF, and the Edgeless RT runtime. These are all projects that are available in the Confidential Computing Consortium, where you can now leverage these projects to get a tight TCB where you have the most control over what gets run on your application and your data when you're operating in an environment. The second use case, the one on the right, is where you want to take your existing application and make it confidential. You don't want to change it. You already got it working, but you just want to make sure that it's a super important business requirement for you to make sure that this application that is running is confidential. So what you can do is get your existing application or your container and run it confidentially with zero or minimal changes. Over here, you can leverage one of the open source frameworks available, such as Graphene or Oclum, or work with some of the ISV partners that we've been working with, such as Anjuna, Fortanix, and Scone. This path, the lift and shift path, is the fastest path for you to make your applications confidential. We've been working with a few customers, and they've been able to get their applications confidential within a matter of days. This is the path that you may want to choose as well for your application. The important thing between these two application models is try to figure out where your trust boundary is. What are you most interested in? Today, we're going to be talking a lot more about the second class of applications where you can lift and shift your existing applications to the cloud. So with that said, today we are very happy to announce a public preview of confidential computing nodes on Azure Kubernetes Service. This is a platform for bringing your confidential workloads and leverage AKS to run them on Azure. These are Intel SGX-based DCS v2 confidential nodes for isolating your execution for Linux container apps. Here, as a developer, the advantages you get are that the SGX drivers are pre-installed with encrypted page cache-based pod scheduling features. It supports existing tooling. So your existing tooling that you already have your existing best practices that you have from a DevOps point of view are aligned with the cloud native development programming model. And it's important to point out that this capability is supported on all GA regions of Azure Confidential Computing VMs running on Azure. In addition, starting in October 2020, we are super happy to announce the confidential containers via AKS. So Azure provides a platform support for these confidential Linux containers through confidential nodes. So what this lets you do is confidential containers will enable existing unmodified containers and all of its code inside the enclaves. These containers provide data integrity, code integrity protection, and data confidentiality in a hardware-based trusted execution environment, thus improving the security posture of your application. So let's take a look at what this means. What we have here now is a platform where you can leverage our ISV partners or open source software and bring your existing workloads and lift and shift them and make them confidential. We are calling this capability confidential containers, where now you're making your existing investments in containers confidential without having to modify your existing app code. Confidential containers will enable existing unmodified containers and all of its code to be able to run inside these enclaves. These containers provide data integrity, code integrity protection, and data confidentiality in a hardware-backed trusted execution environment, thus improving the security posture of your applications. This is a community-oriented approach, and we're trying to help you further harden your enterprise security promise for containers and Kubernetes. In order to do that, we have a really rich ecosystem of our partners that we've been working very closely with to bring these capabilities to the Azure cloud. We've been working very closely with Anjuna, Fortanix, and Scone, who are now providing these capabilities for you to bring your applications to the Azure cloud. In addition to these ISV partners, we've also been working with open source software projects such as Graphene and Oclam to bring your workloads to the Azure cloud and make them confidential. In addition to the ISV and the open source software, we also have capabilities available in the Azure Marketplace on azuremarketplace.microsoft.com that you can now go and deploy these capabilities for your workloads in the Azure cloud. In addition to these, I want to shift gears and talk a little bit more about how we see the Azure cloud moving to the Azure Confidential Cloud. What we've done is we've taken our services, the services that you use, and made them confidential. So I'm going to walk you through a full end-to-end integrated demo showing how trust can be created between organizations to protect that private and sensitive information. So in this demo, we are showcasing the DCS V2 Intel SGX VMs, the confidential machine learning inferencing using the Onyx runtime, Microsoft Azure Attestation Service, and the Azure Kubernetes Service integration with AKS that will now show you how to put all these different pieces together and create an end-to-end integrated demo here.
Hi, welcome to the demo. In this demo, you will see how Azure Confidential Services were leveraged to solve data and code confidentiality problems to build the trust between the multiple parties that are involved in hosting the solution. The business problem lies between three parties, with hospital as the primary customer sharing the patient-sensitive information. All three parties were able to move forward leveraging confidential computing nodes on AKS and related confidential services with Azure for an end-to-end protection. The client is running on Azure Blob Storage hosted on Lumna's Azure subscription, who is the primary customer, and the hospital. A Python Flask-based web API application is leveraging Scone for a lift and shift, and Redis Cache as a storage for a full in-memory encryption. Fabricam here is using a Onyx-based model that Microsoft Onyx team is making it available for running it confidentially as well. All three parties here are able to trust each other through an attestation services that provides transparent attestation of the hardware and the software and the runtime that is included to run these applications. Let's dive into the details now. So on this part, you would see how AKS Two clusters were used to host Fabric and Contoso, where you could add a DC SKU to the node pool that will basically enable confidential containers platform. An heterogeneous node pool was created to run the sensitive parts of the applications or microservices on the same cluster, leveraging the current secure DevOps. Here you see a Python app Contoso is using, that is taking as is and converting that as a confidential containers. Running the Python engine inside of the enclave is only the first step, since an adversary could just modify or replace Python code of the web API. Scone containers are encrypted and IP protected with key release policies attached to the hardware that are transparently handled by Scone. For the Redis component, this is a straightforward process. In this part of the demo, you see the web portal that is hosted by Lamna Hospital as a static website. When you hit the submit button, the Python Web API is called, that is going to the Redis cache, which is all running in an enclave for securely fetching the patient details. If a patient is not found, a form is prompted for the hospital employees to punch in the sensitive information to store back on Redis. So once the information is filled out, the hospitals can also upload MRI scans for the brain and to determine the probability of tumor as an additional data point for the hospitals to follow up on the next steps. The Fabricam is hosting the ML model that shows the tumors, and it is using Onyx runtime in this case that is being communicated directly with Python Web API. For the confidential inferencing, a PyTorch model was taken and converted into an Onyx to be run as a confidential inferencing service. A Microsoft Azure attestation is leveraged in combination with Scone attestation as a key service provider to identify the apps and the hardware they are initiated on. Azure attestation collects enclave evidence, validates it against security baseline, and evaluates it against an attestation policy. Upon successful verification, the service generates a JWD token, and that token is used by the relying party to look at the trust of the overall application. Azure attestation APIs are protected by Azure AD and hence require an AAD token for you to talk. The relying party could be extended to Azure Key Vault or any other Azure services that understand the JWD token for further downstream processing. This is the end of the demo. To summarize, you saw how confidential computing was leveraged to create trust between multiple parties, hospital in this case, how the data and its IP was protected for the containers, and how Azure companion services like Azure Attestation Services and confidential inferencing were leveraged to verify the security posture and have an end-to-end protection. But last but not the least, how lift and shift was enabled for an unmodified Docker apps through a partner. Thanks for watching.
So great, you saw that demo. And this is very important because it shows you how you can bring your own application and run it integrated with all of these services that you saw. And I'm going to introduce those services in the next set of slides to show you what you saw and which services you can now leverage to make your own application confidential. So how does this work? What we now let you do is we help you build an end-to-end solution. You combine the power of Azure services and new capabilities of confidential computing such that your sensitive data is protected end-to-end within your own solution. So this is really important for you as a developer, right? Because as a developer, the amount of concepts that you have to deal with, you want to reduce the number of concepts. This is why we made these capabilities seamlessly integrated into Azure. So you can use your own client apps or your own CI/CD pipeline, use capabilities that you're really familiar with, such as Docker or AAD with RBAC capabilities, obviously, Azure Monitor, and also use your standard computing nodes that you use today and mix and match with the confidential computing nodes and integrate with Azure Kubernetes Service where it makes sense. The other important thing here is because of all these services that we provide from Azure, you can decide which service makes sense for you as you're making your applications confidential. So with that in mind, I want to show you a bunch of services that we are now releasing inside Azure, the capabilities that can now make your applications confidential. So I already talked a bunch about Azure Confidential Computing with AKS. In the next few slides, I'm going to touch on Azure SQL, confidential inferencing, Microsoft Azure Attestation Service, AKV managed HSM capabilities, and a new service that we are super happy to announce, which is the confidential ledger service that is coming soon as well. So first, we want to talk about Azure SQL. Data by itself is super sensitive, and Azure SQL is where you would store the data. So what we've done is we've been working very closely with the Azure SQL team and come up with Azure SQL always encrypted with secure enclaves, which will now help you protect that sensitive data in use while preserving that rich capabilities that you're already used to. This should feel pretty seamless because the capabilities here are you can now do secure computation inside that SQL enclave, where the SQL engine is itself delegating those operations on encrypted data to the SQL enclave, where the data itself can be processed and decrypted safely when it is being actually used. There are rich query capabilities. You can use sorting, indexing, and so on. And the other important thing is we give you that in-place encryption, where the SQL enclave can perform that initial data encryption, and your data is never in the clear when you're moving it out of the database. As you can imagine, for applications that are sensitive, and pretty much all applications are today, this capability will now let you make sure that your SQL database that you're using is completely secure end to end. The other capability we are super excited to announce is the beta for confidential inferencing. Data as itself, a lot of use cases are now using machine learning to operate on the data. Now, machine learning inferencing operates on the real data that you want to get the output on. What confidential inferencing lets you do is it's an open source enclave-based Onyx runtime, which helps you establish that secure channel between the client and the inference service, as an example, where you can now get that confidentiality guarantee from the client data, from the cloud provider, and the ML model provider. This is an example of what is possible. You can get started today by clicking that link at the bottom of that slide to go and read the documentation on how you can get started here. The other service here that is super important is, as a developer and you're running confidential computing, you want to make sure that the code that you're running, the data that you're running, is actually the code and the data that you think you're running. So that code and the data has to be attested so that you make sure that nobody has swapped it out beneath you when you are not looking. Right. So what Microsoft Azure Attestation Service lets you do, it's a free customer-facing service, and it's a framework for attesting your trusted execution environment or your enclave, where you know that the binaries that you're running were properly instantiated on the trusted platform that you think you're running on. So it's a unified framework here that you can now use as a multi-tenant service. It offers default providers. It protects that data in use. And it's a highly available service which will offer the SLA guarantees that you're used to when you're running a cloud-enabled service. There are many use cases here. The way we look at it is MAA service on the Microsoft Azure Attestation Service is a core fundamental building block in order for you to get your applications to be confidential. If you remember a few slides back, we talked about one of the use cases being secrets and key management. With Azure Key Vault Manage HSM, you get a really powerful key management capability, which is fully managed. You don't need to provision or configure your HSMs. It's highly available and resilient. The other important thing is a single tenant. So each managed HSM or hardware security module is dedicated to a single customer, to you, so that you can create a pool of multiple HSM partitions where each pool can have a separate customer workload that you want to run, and make sure that your keys are protected by a hardware security module so that the keys are protected by hardware. The other important thing here that we do want to call out as the move to the Azure Confidential Cloud is that the AKV Managed HSM service itself is built and run on the ACC Intel SGX DCS V2 VMs. And last but not least, we want to talk about the Microsoft Azure Confidential Ledger. In many of these scenarios that we talk about for confidentiality, One important piece that you will realize as you go deeper into this area is you want to make sure that the code and the data that you're running, the logs of it actually reflect who touched the data and the code that you want to run confidentially. So what Azure Confidential Ledger lets you do, it gives you a tamper-proof audit log for storing that sensitive data blobs and records that is fully confidential, immutable, and verifiable. What this lets you do is gives you an audit trail to verify and validate the authenticity of all the data that you're generating. Now, as you can imagine, the use cases of this are multiple. You want to make sure that the highly sensitive admin operations that are happening on your data sets are logged, and you know that the data is completely tamper-proof. You can monitor these multi-party data collaboratives that we talked about earlier. Something like this will let you now audit who accessed the data, what access did they get, what operations did they provide. The important thing here is Azure Confidential Ledger gives you that guarantee that the logs that you're trying to access are completely tamper-proof. So with that, I have a call to action for you. As you get started on your confidential computing journey, I encourage you to check out our homepage on azure.com at aka.ms/azure_cc. This is where you will see all the capabilities we referenced here today, links to blogs, documentation, and product pages. We also encourage you to get in touch with us, as I mentioned when we started the presentation. This will allow you to get in touch with our product team and come to us with the specific scenarios, or if you want to participate in one of the early preview programs that we're running. And in addition, I encourage you to check out the samples that we have published on aka.ms/sgx samples. On that website, you will also find the sample that we talked through today in the demo presentation today. So with that, thank you again for taking the time to listen to this presentation. And I look forward to seeing you on your journey of confidential computing. Thank you.